With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, our question is distinguish between transverse wave and longitudinal wave. Also give one example of each type. And in the second part of the question, it is given that a stretched string of length L is under tension T emits a note of fundamental frequency N. Then the tension is now reduced to T by 2 and the vibrating length is also changed so that the frequency of the second harmonic is equal to the original frequency N. Okay, so we have to find the new length of the string in terms of its original length. Okay, so let us start. First of all, let us differentiate between longitudinal wave and transverse wave. Okay, so let us discuss about longitudinal wave. So we define longitudinal wave as, in longitudinal wave, the particles of the medium in longitudinal wave, the particles of the medium oscillate about their mean position in the direction, or we can say along the direction of propagation of wave. Okay, we can also give few examples of longitudinal wave. And so the examples of longitudinal wave are sound wave. Okay, now we have to deal for the transverse wave. Transverse wave. So here in transverse wave, the particles of the medium oscillate perpendicular to the oscillates perpendicular to the direction of propagation of wave, or we can say direction of wave propagation. Okay, so these are the basic difference between the longitudinal wave and the transverse wave, that in one the particles of the medium oscillate perpendicular to the wave propagation, and in the other the particles of the medium oscillates in the direction of wave propagation. Okay, so we can give the examples of transverse wave as a wave on the string is the example of transverse wave here. Okay, so in the second part of the question, now move for the second part of the question. This is the first part A, and now we have to solve for the second part of the question. So in the second part of the question, it is given that a string is stretched between two fixed supports. Say this is our fixed support and this is the string which is stretched between two fixed supports. Okay, having tension T. The tension in the string is also given in the question. Okay, the tension is T, and given that it is oscillating in the fundamental mode or the fundamental tone. Okay, so the formation of a standing wave for the fundamental mode will be like this. So in this case, we can say that half wave is forming on the string. So lambda by 2 is equal to L. So lambda is equal to 2L here, right? So now the wave speed, we know the formula of wave speed. So we can give the frequency N as wave speed upon wavelength. Wave speed is what? It is square root of T by mu. And what is the wavelength? It is 1 upon 2L. So we have find the value of the fundamental mode of vibration of the original string. Okay. In the fundamental mode of vibration, the frequency is what? N is equal to 1 by 2L root under T by mu. Note it as equation 1. Now in the second situation, it is given that the string length is changed. Now move for the second situation. There also the string is stretched between the two fixed supports, and here the tension is reduced to half of its initial value, that is the new tension is T by 2. Okay, and length is also changed. So say that length is where, let new length is equal to L dash. So L dash is it new length, and it is given that it is oscillating in second harmonic. So the standing wave formation for the second harmonic will be like this. At the two fixed ends, the displacement node will form, and it is the case of second harmonic. So two loops of half wavelength will form. Okay, so here we can say that one complete wave is forming on the string. So the new length L dash is equal to the wavelength lambda here. So the frequency in this case N dash is given as V by lambda. So lambda is L dash here. So 1 by L dash into V can be written as square root of tension, and tension is here T by 2, but the string is same, so it is mu only. Okay, and according to question, the frequency in the two cases same. So we can write according to question, the frequency N and N dash are same. So now we can solve for the two equations. So 1 by 2L into root under T by mu is equal to 1 by L dash into square root of T by 2 mu. Okay, so here we can simplify something or get cancelling. 2 will cancel, sorry 2 will not cancel here L will cancel, no, L is also different. T will cancel T, square root of mu will cancel the square root of mu this side. So the expression is coming as 1 by 2L is equal to 1 by root 2L dash. This implies if we reciprocal the given equation, so it will be root 2 times L dash is equal to 2L. This implies L dash, or say the new length, is equal to root 2 times of original length. Okay, so this is the final expression for the new length. Our new length is root 2 times of the initial length of the string. Okay, so we have solved for the new length of the string. It is root 2 times of the previous length. So we have solved both part of the question. I hope you are able to understand it. Okay, thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.